Hello everybody, I'm Cobbler Bob, and this is my 1971 Cutlass S resto mod. Now that the bodywork and paint is done, and the 4L80E is in and working, we're going to start the buildup of the 482 cubic inch Oldsmobile. Okay, so let's go. Alright guys, I know some of you out there are probably intimately familiar with the build, some of you are not. If you're not, let me bring you up to speed first of all. It's a 1971 Oldsmobile Cutlass S. I'm really not interested in making it a 442 tribute. So right now what the car has in it, the axle is a Chevy 12-bolt axle with all the goodies in it, including Mosier 7900 weld-on axle ends, Mosier 33 spline axles, Motive 342 ratio ring and pinion, with an Eaton True Track posi traction. The axle was built by Brian Trick in Erie, Pennsylvania. It's painted, as you can see here, to look like one of the 400 and some odd W27 aluminum center section axles, and it does have a W27 alloy cover. The transmission is built by Rich at Cyclone Transmission in Canton, Ohio. This is a 4L80E. This is electronically controlled, 4-speed overdrive. Mine is a 1997 model year, so it's built also to handle about 800 horsepower. The engine for right now is a stock Olds 350. It's got number 8 heads on it, which means it's 1973 to 1977. So as far as the fuel system on it, it's got a Holley Terminator X. That was a very recent episode. I'll put a link in the description below, but it's a Holley Terminator X Max Stealth 4150. Electronic throttle body fuel injection. The reason I chose that is not just the benefits of fuel injection, but the Max Stealth also runs the transmission, so I didn't have to spend another $1,200 on a transmission control unit. It's built into the ECU, the computer. It does run, it does drive. Oh, the drive shaft is even ready to handle the new engine. The drive shaft is a 84 thousandths wall, 3.5 inch diameter drive shaft, brand new, custom drive shaft with 1350 U-joints, heavy-duty yoke, and that was built by Custom Clutch, Joint, and Hydraulic in Canton, Ohio. This is a street car that I'm going to race. That's very different than a race car you drive on the street. It's got heavy stuff in it. Air conditioning is not hooked up yet, but the components are there. It's got a full interior in it. You can see it's got headers on it, but these are the big block headers. Those are American Racing 2-inch primary stainless steel headers that will go on with the new engine. And as I was saying, the interior, it's all there except for the headliner, but the rear seats are there. Obviously the dome light's not hooked up, but got the new interior in it. This was a bench seat, ugly brown interior car when I got it, and it just had the regular gauges, and it's even got USB charging in the rear passenger seats. Not too shabby, huh? Right? When I see an old Oldsmobile especially, I want to see an Oldsmobile engine in it. I have zero interest in putting an LS or any kind of Chevrolet engine in it, so I'm keeping it all Oldsmobile. So the new motor is an Oldsmobile block. It's Oldsmobile, it's going to be 482 cubic inches. How do you do that? Well, the largest they made from the factory was 455. So I'm starting with the 455 block and a 425 crank. Well, why am I starting with the 425 crank? Well, the Olds 455 cranks are somewhat hard to come by. They didn't make very many steel 455 cranks, but every 425 crankshaft is steel. The reason I'm using the 455 block and not the 425 block that the crank came out of is that my 425 block had actually the 0.921 inch diameter, in other words, a larger 0.921 inch diameter lifter bores. Some of the old engines also had a 45-degree lifter bank angle instead of 39 degrees, so 39 degree lifter bank angle is more common, and the smaller 0.842 lifter bore is more common. The problem with the 0.921 lifter bore is that you basically have no choice of aftermarket hydraulic roller lifters. So 455 block, it's a 1968 block. It's been sonic checked. What that means is, basically they, I don't know, put sound waves through it, I think. And then they can check to see how thick the cylinders are even where you can't see them. And the reason you do that is if you want to go large overbore, which mine is. It's going to be 125 thousandths overbore. A standard overbore when you're rebuilding an engine is 30 thousandths, which you take off, and also offset grinding the crank. I'll explain offset grinding the crank. Basically, if you have a main bearing journal and then the rod bearing journal, okay? Oldsmobile has a 2.5 inch, very large diameter rod journal. So when you grind it, you would turn it down smaller. Oldsmobile 2.5-inch rod journal is getting turned down to 2.2 inch, the same as a Chevy big block, which reduces bearing speed, which is good. But we're not keeping the center at the same point. What happens is when you're grinding the rod journal, you don't grind it down on the center, you grind it, but you take more off, right, towards the center. So you move the center of the rod journal as you grind it smaller. So the stroke will be back to the 455's 4.25 inch stroke. So 4.25 inch bore, 4.25 inch stroke. Then you wind up with 482 cubic inches. You'll obviously have to get a custom rod and then a custom compression height piston to make it all work. Okay, so, but that's kind of the basics. It should be big cubic inch. It'll be, lumpy, a little bit radical, for the street. But I think it should be fine for what I want to do with it. And it should be an all around fun car. And we're targeting somewhere between 550 to 575 horsepower. Oh, the camshaft we've chosen is a hydraulic roller camshaft. There's really no downside to a hydraulic roller camshaft other than it's a lot more expensive to put in because now you have to buy roller lifters. You generally have higher valve spring pressures, which means you need more head work. It drives up the cost of everything. But hydraulic roller cam is 605-inch lift, 609 exhaust, and I believe it is 249 degrees duration on the intake and 243 or 245 exhaust. It's 112-degree lobe separation angle, which is, a little wider. So it's, not going to be the most radical thing out there, but you're definitely going to know it's got a big cam in it. Compression should be, I believe it's going to be around 10.5 or 10.8 to 1, something in that ballpark. So it's going to be about on the edge of what you want for a street engine, but, larger camshaft and aluminum heads and a good cooling system, you can do that. So first, let me introduce you to my engine guy. My engine guy is Mark Smith. He goes by Smitty, M&J ProFormance. He's an Oldsmobile specialist. And actually, the engine that was in my last car, which is this one right here, this engine was built, it was a 455. This was closer to a performance stock engine. It had factory rods, ARP bolts, ARP stud kit, a nodular iron crank, ported iron heads. This car went 1239 at 110 miles an hour. It was an 86 Cutlass, and just like I said, C heads, and that was a 204R transmission, 239 cam was a 239 duration at 5541 lift. Nothing crazy special, but a wonderful, wonderful street car, but it got stolen in 2004. All right, welcome everybody. I'd like to introduce you to Smitty from M&J ProFormance. He's the guy that built the previous engine in my 86 Cutlass, the first guy that I met anyway that really, I think, understood Oldsmobiles, what's specific to them. And if you want to introduce yourself, Smitty, as far as what's your experience with Oldsmobiles and what's your background?
Did my first one along with my brother in 1982, I believe. And it's just been a learning experience from there. Started building them professionally in the mid-90s when I finally had my own place. Always worked full-time as a tool and die maker. So measurement was my thing, making stuff precision.
Mm-hmm. And when you say tool and die, I don't think a lot of people know what that means. What kind of dimensional tolerances are you talking about in the tool and die business that you'd have to hit?
We basically work to the 10,000th of an inch.
Wow.
So cut a 1,000th of an inch into 10, and we're working to those.
Right. Yep. And that's your car above your head there, right?
Yes. And we've also, if you're in the grinding part of the trade, where I was at, we'd work to 10 millions.
Oh my God. Really?
Yes.
Okay. Holy crap. Wow. That's crazy. You want to talk about about how many engines do you think Olds you've put together? And can you talk about the one, your car there pictured above your head?
I've built hundreds upon hundreds of them. And yes, I had my failures because I didn't have the internet to learn from.
Yeah. Mm-hmm.
The engine that's in my car, the first block first off, it is a 4-bolt mains conversion, a 425 crank that's been offset ground to 2.2 big block Chevy journals with a 4.25 inch stroke. Block is 60 over, so it's a 468. 12.2 to 1 compression, iron heads, and it has been 1036 at 128 mile an hour at Norwalk.
Wow, 1036 at 128 with iron heads, no nitrous, no supercharger.
Correct.
And what size tire? How
That was
wide?
probably a 10.5 inches, either a 9 or a 10.5, depending on what I had on it that day.
Iron heads, that's pretty impressive. And what was more
Well,
impressive to me than that is how
this,
long you have it together.
well, especially the fact that it is an all steel car,
Mhm.
full factory interior. You look at it, you think somebody drove in off the street and put slicks on it.
Right, right. Yep, yep.
Even has mufflers.
No glass bumpers. It's all steel bumpers, chrome bumpers, right?
Yes.
Yeah,
Yes.
yep. And how long was it together like that?
Came out of the paint shop, I think in 97. That motor, the first block had about 3,000 passes on it.
Wow.
Pulled it apart just to see what was there. Everything was in great shape except for the cylinder decks were cracked on one side.
Uh-huh.
So we put another block in it and put it back together. And right after that's when I had my neck broke and I just kind of had to stop.
Wow. Wow. Yeah. So that's the thing I liked is you know how to make stuff last and put together. And after you did my motor, the one, the car that got stolen in 2004, man, it just the way it revved out. But man, I'd go through the traps at 5,800 in third gear. And it just that motor just sang. It just felt so comfortable. You could drive it. I had oil cooler on it, and you could drive it for 2, 3 hours, race it, and the oil pressure was rock solid the whole time. It was just felt great the way that motor worked. So
Yeah, well, that's when you guys drove all the way to Bristol, raced it, and drove home.
yeah, yeah, absolutely. Oh, that was a crowning achievement for that thing. Yep. We raced it in
Yeah,
From Ohio to Bristol, Tennessee, drove it there, raced it the whole weekend, then drove it from Bristol back home. So
yeah, and that wasn't just Saturday racing. That was Friday night, Saturday, and Sunday. When I remember,
yeah. Oh, that was great.
we had a heck of a good time.
Yeah, absolutely. Absolutely. Um, so if we want to talk a little bit, Oldsmobiles are unique in some ways, correct? We want to talk about what some of the
Yes.
weaknesses in the Oldsmobile oiling systems, small block and big block, we're trying to overcome.
The small blocks don't have a lot of oil issues. The big blocks have the issues. The big
Mm-hmm.
mains, it's hard to feed them. The oil passages in them are a little longer. The oil passages in them are undersized. They're just not big enough to flow the volume to run over about 4,500 RPM.
Oh, no kidding. Okay. Is that because they're the same size holes as a small block? It's just a tall deck small block with big mains and long strokes.
Yeah, well, that and the diameter of the mains are so much more bearing speed.
Mhm. To clarify bearing speed, if you have a journal this small traveling at 5,000 spinning and the crank is going 5,000 RPM, and you have one this big at 5,000 RPM, it's like being farther out on the what do you call
Right.
the merry-go-round when we were kids, at the local park. Like you could
Yeah.
stand in the middle of it, and there was not much centrifugal or centripetal. I don't know which force, but if you were at the edge, you'd like feel like you're getting flung off, right?
Right.
That's the general principle. Okay, so that the speed between the bearing, and the
Right.
crank relative speed is higher with a larger journal. So that's what is it?
So,
2.5 inch main on a small block Olds, 3 inch on a big block, right?
right.
With the exception for the diesel small block, which is also 3 inch.
Right.
Okay, gotcha.
So
And
what we do to overcome those issues is we drill out the passages in the block. You'll show that there later. Uh, we open up the passage in the rear main cap. We open up the passage from the rear main cap all the way out to the oil filter, and from the oil filter back into the end of the block, down through the block to the where the main passage goes up beside between the cylinders and the center of the engine. We open all that up so we can get the volume of flow that keeps everything alive.
right. Okay. 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 Awesome. And you talked about the offset grinding, which we'll show in detail, but so that makes a big difference too, then. I mean, obviously you can increase the stroke. You can get a 455 stroke out of a 425 crank. It also gives you a steel crank because 455 steel cranks from the factory are hard to find. Aftermarket ones are thousands just for that part, right?
Exactly.
So it kind of gives you the best of both worlds, I guess, in a way.
You got it. Makes it a
Okay.
whole lot more affordable for the average Joe.
Okay. And then that reduces the bearing speed because you have a 2.2 inch rod journal rather than 2.5, right? That helps
Right.
it. Okay. Awesome. And then you can also get Chevrolet big block rods like we did for my motor, and a bunch of other people do, which are just more commonly available, a lot more choice, right?
A lot more choice, whole lot cheaper.
Okay. And what about the rod width? Are they the same width or they have to be modified without getting into much detail?
Uh, Depends on who grinds your crank. Some guys will widen the journal so the big block Chevy goes right on, or you can take the big block Chevy rod and narrow it to put on the old width journal.
One of the two. They're close, but you got to modify one of the two.
Yeah.
Okay. What else would you say with the oiling system? Bearing clearance is something you've taught me about, that we went through a big. I think the bottom line was when my engine was done the first time. I mean, to be done right, correct me if I'm wrong, you have to have the block done. When I say done, I mean the mains sized, if they're being reline bored and line honed to size, torqued, bearings assembled, then you measure the inside diameter with the new bearings, and then you tell the crank grinder how big to grind it. And then you get the clearance that you want, right? Otherwise, there's no way you're just guessing it's a pot shot.
Correct.
Yeah. And I think mine the first time came out, the mains were I mean, this is 23, 24 years ago, but I know they were over 3,000s. I know I did not have good oil pressure when it was hot. And like I said, two different times. One time it actually spun a rod bearing. The other time, oil pressure was just dropping, and it just would have been a matter of time by the time that happened. And I know once you did it, it was just a different engine.
Yeah. I usually on a street motor, now even my race motor when it first went together, 2 2/10 on the mains, same on the rods.
0.0022,
Yes.
what you're shooting for. Yeah. Wow.
A lot of the builders out there just scream and cry, "Oh, there's no way you can do that." Well, we do it, and I have the precision instruments to prove what I've measured stuff at.
Mm-hmm.
Um, you put 3 thousandths of an inch on a street motor, and you truly drive it.
Yes.
It ain't gonna last. You're not going to go cruising down the highway at 2,500 RPM and have that bearings last. It's just not going to happen.
Yeah, I think that's what mine was, is 3.5 thousandths. I think closer to 4 on the rear main, and just never could generate good oil pressure.
Right. Yours were right around 3.5. They were really high.
Yeah. Because what the theory is, they say let stuff move around, but I mean, which might be okay if your oil never gets hot, right? In other words, you just trailer it to the track,
Exactly.
and let it sit. But, yeah.
And there's a difference on what bearings you use. Most main bearings have, especially your passenger bearings, all just have a groove the entire way around the bearing.
Mm-hmm.
And you get to the race bearings, uh, Cleveland has one that has only a top half groove. Federal Mogul, they also go by Speed Pro. They have a 3/4 groove bearing, which is usually what I use. By having that full width of that bearing on the bottom, it more than doubles the capacity of the bearing. Most bearing sets have that groove goes the entire way around top and bottom.
Yep. Oil comes
Then
from the
that is
top.
actually a Cleveland, or I'm sorry, that is a Federal Mogul bearing with a 3/4 groove. So the full groove goes on the top, feeds oil. Then the bottom has,
And right
as you
here,
can
this
see, the
oil
bottom
fill.
of it has no groove through it. So you get it's more than double the strength of an oil film because
Mhm.
it's not cut in half.
Right. So the oil, this is the top shell, and the oil comes through here from the main galley,
Right.
right? And then goes through this groove, and yeah, that makes sense. That makes a lot of sense. You get a much greater load carrying capacity. Any downside to using it?
With that bearing, you have to have more clearance.
Oh, really?
But you need to be 2 7/10, which would be 0.0027
Mhm.
or greater to use that bearing if you're going to run a heavyweight oil.
Oh, really? Okay. So for
Yes,
someone
because
like,
that being solid on the bottom like that,
Mhm.
if you try to run it tight at less than 2.5, it will actually lift the crankshaft into the top shell.
Whoa, no
I only
kidding.
know that because I've done
Wow.
it.
So for my application, the street strip application, where are you going to see, we're going to use these, and where is the clearance going to be set at?
There's a lot to that. For the average guy who's going to go out and run a 20W50, I would set that at 3 thousandths.
Wow. Okay.
If you're a person who trusts modern technology in the oils,
I do.
I would probably set that down around 2.5 and then run like a 530.
Okay. Okay.
If there's the cam bearings, the top is just your standard Oldsmobile cam bearing.
Mhm.
The bottom is a Durabond 06 bearing.
Ooh.
Oldsmobile, in their great wisdom, decided that they should feed the oil directly under the bottom of the camshaft where it is under its greatest load.
Okay.
But of course, they didn't figure these motors would ever see north of 4,000 RPM. They were
Okay.
built for land barges.
Right, right.
So then you start putting solid roller cams, especially solid roller cams that have 300 pounds on the seat. There's a
Uh-huh.
lot of load on that bearing. I mean, a lot of load on that bearing.
Huh.
So by rotating the hole up to about the 3 o'clock position, you pull the oil under and make a bearing, film and an oil wedge that you can't do with the standard bearing.
That makes sense because then the oil is being fed before the load area, not in the middle and after it.
Right. So the bearing can pull the oil under it and build a bearing oil wedge.
Yeah, I do remember studying
And
engineering. You think it's round and it's even all the way around and it's not. There's a greater pressure. There's like this. I've seen graphs of it. It's complicated stuff. So now we've discussed some of the bearing clearance stuff, and that's fun to talk about. But what I think some of the stuff that's not fun to talk about is I'll try and see if I can find a picture here of the mains. But didn't you say with my engine it wasn't straight, right? And blocks
no,
move.
your block was warped a lot.
Yeah.
So it took some machining to straighten things back out.
Wow. Wow. And this is your design, wasn't it? That you did this, what, 20, 25 years ago or something? You made these on the Bridgeport bit,
Yes.
at your Bridgeport
Yes.
sewing machine? Yeah.
Yes. There's two people that offered the 4-bolt main back then.
Oh,
Dave
wow.
Smith Engineering out of California, of
hmm
whom I did not know them at this time,
hmm
and myself and Scott Grossenbacher were wanting a way to make these things stronger. So I came up with this 4-bolt design.
hmm
After I did this, someone told me that Dave Smith already had it. So I did not copy Dave. Dave did not copy me.
Gotcha.
I do know the ones that are out there now by someone else are like mine.
hmm
They're a whole
hmm
lot prettier, but they're off my angles and whatnot. There is a
Okay.
difference between mine and Dave Smith's, which is just minor, but we came up with the same thing, only different.
Gotcha. And yours are steel, right? Billet steel.
Yes.
Okay.
Yes, they're steel. You can do them out of aluminum too.
Mhm. To me,
The
steel would
steel is
seem,
just an easier option.
yeah, yeah. And if you notice here, I don't know if this next picture shows it better. The holes for the outer bolts, by the way, number one is splayed, right? You want to talk about when
Yes.
they connect and why that hole, if you can see there, that hole is not in the middle of the cap. You want to talk about that?
Yeah. Well, if you look at the web that's underneath it,
Mhm.
the web itself is offset to the opposite side.
Here's the
So you
web.
have to offset the hole, and you go down in with a flat bottom drill and you remove just a wee little bit of the web sometimes.
Mhm.
Then you put a drill bushing down in there that goes all the way down, and you drill the hole through the block and then tap it.
Wow, wow. So what that's doing is you're actually, it'd be over here, right? Like if I drew on the block, like on this side, you would be what? Like, does it go right about here? Something like that?
Yeah. Yeah, you actually goes right in, right centered on that corner.
Yeah, which is the bottom of the cylinder, right, of the block.
Yeah.
So now you're distributing load not just from the middle, but you're tying it into the cylinders on the outside, which I think is awesome.
Right.
Yeah, because otherwise, I mean, what are the other ways to do it? What is that called? Is it called a bed plate or a girdle?
Yeah, you can do a bed plate, and I'll send you some pictures of that.
hmm
Uh, you can do a bed plate. Mondello had a deal that was a weldment that went over top of the caps and
hmm
bolted to the bed rails. There's a whole lot of ways to do it. This way here so far has been bulletproof. It has withstood the test of time up to 875 horsepower.
Wow. Okay. Okay.
And that particular motor was ran for many years. And the guy tore it down because he just had a burr to tear it down. I don't know why. It was running great. And
hmm
his neighbor was actually a federal mogul engineer.
Yeah.
and he looked at the bearings and told him put the bearings right back in it because there's nothing wrong with them. And they did. They put the bearings right back in it.
Wow. Front is 2 bolt. You don't need no need for the 4 bolt main on the front. There's just no room
Right.
to package it.
No
Okay.
need for it. There's no place to put the splayed bolt on the one side.
Gotcha. And on the back, then this application using the stock rear main. Just got a bunch of passenger
Yes.
oil. Okay. Well, it's a beautiful, beautiful setup. So yeah.
If Peyton would have had his new rear main cap made, we would have used one of those, but we didn't have it then. And
Gotcha.
that rear main cap is so beefy that it really, you don't need to.
Okay. Okay. Yeah. Now you said mine was warped. Can you talk about what was warped on this block?
So let me see where I'm looking at. From the bottom front corner
Mhm.
to what would be the top back corner,
So
that
like,
block had a twist of almost 30 thousandths in it.
so from here,
No, down here,
where? Down here?
down in this corner. Yeah, from where your pointer's at,
Yeah.
from there to the opposite corner,
Uh-huh.
up
Up there.
there,
Yeah.
that block had a twist of almost 30 thousandths in it.
30. That's a lot, right? Wow. Then
Yes,
you say that blocks after they're cast without cracking, they season, meaning things the internal stresses, they stress relieve, right?
yes,
I remember learning in engineering, stress relief happens through heat cycling and through load and vibration, right?
yep. And I must say that is the absolute worst block I have ever seen.
But it's not going to hurt the final result because I can see that like the pan rail
No,
has been machined.
correct. It's gonna be all everything comes off that main bore when it's done. So
So you've trued it.
yes,
Wow. So,
I had to true it up so I could set the clearance on the cap so they'd preload.
okay. So exaggeration here. If this is where the main caps was sitting, I mean, mine was like I don't know which way, but it was like this. Obviously, that's exact.
Correct,
Wow, that's
correct.
insane. That's insane. And then you're also sizing the holes, right? Because when you don't you mill a little bit off of this surface on the block, this part of the surface of the block, if the caps weren't there, aren't you milling some off of that?
On your block, I had to, yes,
Okay. And then because you have a smaller hole, because you're creating this hole in the block, in essence, what that lets you do is shrink the main bearing hole down and then size it to where you want it, kind of, right?
correct.
Wow.
But when we're done with it, it will still be back in the exact place it was on the factory. So when you go through and you bore all the material out of the caps, you
Yeah.
won't touch the block.
Okay.
Then when you line hone it, we'll just line hone it until it just barely starts to scratch the factory surface.
Okay.
So the center line stays in the same place. So your timing chain and all that stuff you don't have to be buying 10,000 short timing chains and all that.
Gotcha. That makes sense. That's awesome. I guess that after talking to you a few times, I guess the big thing I see is it's not which parts you throw at it. Like I was asking you back, in the day everyone had to use these oil restrictor plugs that plug the hole going up to the camshaft. And it's like it's not about what parts you throw at it it's as much. Or maybe that's not the entire secret. Part of the secret is just having mains that are round and 5 of them that are in line with each other, right? I mean, accurate machine work and then having everything held in place where now the mains are tied to the cylinders where you have a stable platform to be able to throw power at it, right?
Exactly.
And like you said, opening up the oil hole so the oil can get there. That stuff's not sexy. You know what I mean? To say, hey, my oil holes have been enlarged to 5/8 of an inch. Oh, really?
Exactly.
Yeah, but as you'll see later in the video, I was stunned how big of a difference there is, but we'll get into that later. So awesome, awesome. Anything else
And
you
I
want to?
believe you also have the picture where underneath the rear main cap, the top bolt in the rear main cap, where it screws into the block, is actually a through hole.
Oh yes, yes. That'll be
Because
shown. You need to bring. Yeah, that'll be.
that is the tap drill size for that bolt is also the feed size for the oil feed that carries it from the oil filter, carries it vertically up the block to the main oil galley that runs down through the middle of the block.
And you wind up getting a restriction there, right? As a result.
And that's a major restriction because it's not even a 1/2 inch hole. So we
Wow.
go in and we drill that hole out for a Now I use a timed insert. You can use a jerk insert. It doesn't matter. They all do the same function. Drill it out, retap it. And then that gives you a nice big hole up there for that oil to make the turn from, it's got to make two 90-degree turns. And that gives the oil room to make those turns, a bigger passage, less restriction, so on and so forth.
Nice, nice. All right, Smitty, thank you so much for your knowledge on this and stuff like that. And like I said, there's, you know, when I knew I was getting back into this, and I know you might have been surprised to hear from me after a 19-year hiatus, you know, a lot of people thought I was out of the car business for good, but, you know, I knew.
Yeah, let me record one more thing here that you can edit in at the beginning.
Yep.
Well, I did this for a long time. When I had my neck broke, I was forced to just stop. And I really had no intentions of getting back into it.
Yeah.
Then one day out of the blue, I get a call from this guy that I built a motor for once before. And asked me if I would do his. And I told him, well, Bob, I'm really not doing any of that, but since it's for you, yeah, I'll do it. But you can't be in a rush.
Yeah.
Because I just don't move that fast with the damage from having my neck broken and the damage in my hands just from being a tool and die maker all those years.
Right.
I have a lot of bad days.
Yeah.
And I've also got damage in my spine from the big accident.
Yeah.
So told him you just had to not be in a rush.
Yeah. You know,
told him, you just can't tell anybody I'm doing this.
Yeah.
Yeah. 3 or 4 days later, I get a call from somebody else asking me if I'd refresh their motor for them that I built. Because Bob didn't tell anybody.
I think you told him, did I?
Yeah, you told Dave Worthington.
Oh, I did? Okay. I don't know. I guess I missed that part.
Yeah, so I've got Dave Worthington's. I refreshed Dave Worthington's motor over the last year. And hopefully we'll get the dyno both of these at the same time, back to back.
Yeah, that'll be sweet.
But I'm not doing this commercially.
Yeah.
If somebody wants something, I'll gladly build it. Yeah. If you want some of the hard parts we've used here, I'll gladly make them for you. You just can't be in a rush.
Yep. That's going, you know, that worked out for me because, you know, car's got a motor in it. And I mean, it's been down for a year. Even if the motor was done, it would have still been down till now anyway, you know, so.
Right.
Except one not putting any roof and floors on the thing and painting it and all that other good stuff. But
it snowballed.
Yeah. So yes, yeah, it did. Awesome. Thank you, Smitty. I appreciate it. And we're going to definitely have some more segments on this and, you know, show people exactly the nitty gritty of how this stuff works.
All righty. We'll catch you later, man.
Thank you.
All right. Bye-bye.
I'm going to give you guys a peek into some of the work that's going into the motor. All right. And diamond pistons. The motor that's in the car right now is an Olds 350. It's pretty weak. It's a small Gara engine. The reason we know that is with Oldsmobiles, the easiest way to generally tell that motor is, first of all, if you look at the top of the engine here, this area here, the timing chain cover is completely flat from side to side. If it was a big block, it would have a raised rib, but flat means a small block. Then you look here at the head. Basically, the long and short of it is, lower that number, usually the better. Number 8 is a small Gara head. It's the worst head. You have 7A and 7. 7 with a small A is pretty good. 5, 6, those are really good heads. But the point is, this is a small Gara 350. But here's the pistons. I'm not going to give you all the details yet, just because there's some things still in the works and, you know, et cetera. But these were not cheap, let me tell you. It's actually a custom piston. And some of the specs on it, just in case you're curious. They're pretty big for an Oldsmobile anyway. 4 1/4 inch bore. Not all Oldsmobile big blocks can go that big. You got to sonic check them. But if you see the compression height, 1.375, that is definitely not stock. And it's getting Chevy big block rods. It is still an Oldsmobile block. Oldsmobile factory crank, steel crank. But look at those things, aren't they beautiful? Forged pistons. And they're coated, they're ceramic coated. So total seal rings, right? And we got some wrist pins as well, and spiral locks. A little peek into what's happening. These are aluminum Speedmaster cylinder heads. We bought the bare version, and this was before that Speedmaster controversy where, Summit dropped, stopped carrying them. But you can see here, valve throat there isn't the greatest. Obviously they did machine it, and then here the intake port, they CNC port matched the port, but you can see especially on the port on the right there, the blend is very poor. The port floor there is very, very rough. It's a little bit inconsistent there. So it's not the greatest, but these are going to get ported, actually CNC ported by Peyton Hunt at Performance Driven Design. And, you can see there, the exhaust side, there's a little bit of a lip and a bump there. The casting flash. And like I said, the transitions between the machined areas and the casting is not very good, but that'll all get taken out with the custom CNC porting job. So this is at least the starting point. You'll see more on these later. And here's the crankshaft. If you notice, it's been polished. You can see the casting marks have been removed. You can see there that it's been turned down offset ground by looking at the cheek of the rod throws there. Standard on the mains, 10 under. And then the rod bearing journals are turned down to Chevrolet Big Block, standard Chevrolet Big Block, 2.2 inches. Oil holes transferred, and it's been ion nitrided. And ion nitride is a treatment that brings the surface hardness, gives you a hard surface for the bearing journals.
Ion nitrided, which hardens the entire.
So I'm going to conclude this first part of that 482 cubic inch build-up video here. And you're going to see here, check back almost immediately, another video is going to be released. This video is going to actually show how these modifications are done. This is going to center around the oiling system and the oil passage modification, so don't go anywhere. Thank you so much, everybody, for watching. Go back if you've missed them. Most of my subscribers have missed most of my videos. Remember, there's cobbling, shoe stuff, sartorial stuff, and there's cars. I have playlists set up. So please go back and check them out if you've got a few minutes and you want to be edutained. Thank you guys so much. God bless. Have a great day. There's my marks.